Okay, let's recap. We are 2 videos in, and this is the third. In the first video, we showed a no-code version of the digital twin entirely built on the Cartesia playground, fully functional with a telephone number that recruiters can call to speak to your digital twin and find out about your professional work history. In the next video, video 2, we wrote a little bit of Python code using the very intuitive Cartesia Line SDK and added tool calling to our voice agent. Specifically, we gave it the ability to look up files and search the web using tools from Tavily. And now we're at video 3, where we're going to extend our Cartesia AI agent even further by adding another tool, an email tool, using a fantastic product called AgentMail. AgentMail gives AI agents their own unique email service and the ability to send and receive emails without having to go through all of the hassle of OAuth and things like that. At the end of this video, we will see our voice agent do 2 things. 1, any call that connects to our voice agent will trigger it to send us an alert email as the operator of the voice agent. And 2, the voice agent is going to offer to send the caller an email transcript of the conversation after the conversation is done. This is pretty cool because getting emails right and spelling them out in a normal sounding voice is a pretty advanced capability, but something that Cartesia's TTS models handle very well. Now, before I switch to the code editor, please make sure you go to agentmail.to and sign up for your free account. In fact, you can run this entire demo without any problem on the free account, and it'll take you about a minute to set up. It's pretty intuitive, and you'll be able to follow the instructions there. Make sure you set up an inbox and you get your API key. Then add your API key and your inbox ID to your .env file. You can see here that we have it in our env example file. So you have the AgentMail inbox ID, the API key, and the user email. Now, the user email is simply your own email address where you'll be receiving call start alerts and also the transcript at the end of every call. Once you've updated your .env file, don't forget to run Cartesia set env and then from the .env file. When you run this command, it's going to push from your .env file into the hosted Cartesia environment so that your runtime can actually access these environment variables. But don't forget, you can also just go directly to the deployed twin. If you followed along in previous videos and you already have a deployed voice agent, you can go there and manually put it into the environment tabs here as well. And you don't have to use the CLI tool. Of course, a lot of people use the CLI tool because it's very fast and it's in your dev workflow. By the way, that reminds me, if you've not followed along the previous videos, then you can still listen and watch to this one. But if you want to actually code along, you're going to have to watch the video about adding tools via the Line SDK first, because we are extending the voice agent that we built in that video. Now, it's not long, it's only about 10 minutes, so it'll take you no time at all to get up to speed, but then you can continue coding along with this one. Great. Now let's first go over the stuff that hasn't really changed. So if we open main.py, you'll see that a lot of the stuff is kind of familiar if you follow the previous video. This hasn't really changed very much. The pre-call handler, we still set the text-to-speech configuration here and return a pre-call result object that has a pointer to a voice clone ID. If you haven't followed along so far, then you're going to have to look at the other previous videos to see how to get your voice clone ID, how to create your voice clone. You can look at the no-code video for that, and it's all available in the Cartesia dashboard when you actually set your voice clone ID there, right? Or you can do it programmatically here. And we've chosen the model to be Sonic 3.5, which is Cartesia's state-of-the-art text-to-speech model with really high naturalness and emotion, or emotiveness to be very precise. We've set the language to English. And so it's kind of the same. And here's the app. Here's how we instantiate the app. We create a voice agent app, which is something that you get from the Line SDK. And we pass in the get agent function and the pre-call handler function, both of which have been defined here. The get agent function does look different from the previous one where we added tools, but I'll get to that in a moment. And if we switch over to tools.py, we see the read resume tool, the file reading tool is still here. As you can see, it's a loopback tool, which is a primitive defined by the Cartesia Line SDK. It loads the file exactly as we did in the previous video where we're adding the tools. And again, this is also unchanged. The Tavily tools, which exposes to tools underneath the Tavily tools class. The tools here are declared in a class rather than this read resume one, which is just a function. The Tavily tools are in a class. There are 2 here, the web search loopback tool, and you have the web extract loopback tool. Again, so far so good. Not many changes to the tools.py so far. Now, where things have actually changed is this email agent.py file, which is where we've added all the tools regarding the email agent, but we've also now declared the LLM agent here. For those of you who followed previous videos, that'll make a little bit more sense. Now, if you're a developer, then this may look like a lot, but it's actually pretty straightforward. If you spend 5 to 10 minutes reading the file, it'll all become clear to you. And we're going to walk through it now anyway, but it is for developers. And you'll see here that this file has one wrapper class, the DigitalTwinAgent, that wraps all the functionality we're going to need, including all the other tools that we've already covered, and in fact declares its own loopback tool here at the bottom. But we're going to break this down in a little bit more detail in a moment. But this is now the real hub of our code because it has all the functionality and the actual agent definitions that we're going to use. So to start understanding this file, let's take a look right at the top here where we see that we're actually accessing the 3 new API keys that we've declared in our .env file. And of course, we have imported AgentMail at the very top here to make sure that we can actually use the client library and actually send email correctly. Now, if we study the email agent.py file a little bit closer, we'll see that all it's doing is it's declaring a digital twin agent class here, right? That's going to wrap the tools, but it's also going to wrap the actual LLM agent that powers our conversational voice agent. The reason we've designed it this way is so that the wrapper can intercept call lifecycle events, because of the way the Line SDK has been designed, it gives you APIs by which you can access critical pieces of information and metadata about the actual agent infra that's running around the voice agent, and also call details and pieces of history so you can build the transcript. In fact, we do have to build the transcript, something I'll talk about a little bit later in this video, because we need to access each of the input events from the user and the response events from the actual voice agent back to the user. And we need to assemble all that so that we get a clean, nice, readable history. And if we dive a little bit deeper into the digital twin agent now, we will see that it's initializing with a bunch of data, right? So it's mainly the API keys at this point of time, and then it assigns to its class as member variables things like the inbox ID, which is your AgentMail inbox ID, the actual owner email, so the email that will receive the notifications and things like that, which is your email address, and then establishes the AgentMail client and gets a piece of metadata from the Line Agent SDK about the call request, because we need to pull off pieces of data from that when we're actually responding to end users and so on. So all this is doing is starting to consume a lot of our environment variables at the time that this class is actually instantiated into an object. And then we're connecting Tavily as well, and we're saying, okay, here's the LLM agent, right? This is the brains of the voice agent, if you like. We're connecting to Anthropic Claude. We're giving it all the tools, as you can see here, including the ones from the previous video, the read resume, the Tavily tools, and now we're going to have the send transcript to caller tool, which I'll get into in a little bit more detail in a while. And of course, there's a prompt as well. Now, in the previous version of this app, this LLM agent was actually created and instantiated inside the main.py file, right? It was actually done here inside the getAgent wrapper method. Now, getAgent gets passed to the voice agent tab here, and previously we had the creation of that LLM agent object over here with all the data passed here. But now we've moved it to this email agent, and I've done that really not because it's necessarily the best pattern, but mainly so that when you're reading email agent.py, this is now going to be a focus and it's all there in the one file. So I've really done it for your readability. So this digital twin agent class is now responsible for creating and instantiating this LLM agent and is able to delegate work to it and also data to it as required. So as you can see, we've changed our pattern a little bit. We've now moved to a digital twin agent class and a class that wraps the LLM agent. Previously, like I said, we just declared the LLM agent and instantiated it here and returned it under getAgent, which means now what we're doing is returning the digital twin agent class. So clearly we moved from getAgent returning the result of a LLM agent method call to now returning a class. And that's possible because the Cartesia Line SDK does expose 2 ways in which you can respond or return data from a call to get_agent. In our case here, we're giving it a class, and such a class must implement a method called the process method, right? So this is part of the defined API. Any agent that implements the process method can be returned in the getAgent call. So what does the process method do? Well, it takes in two arguments. It gets a env argument and an event argument. The env is really just the background metadata to what's happening in the agent. It is information about the actual agent, the runtime, and the turns. And the event object has key call lifecycle events because that's what the harness is passing back to your application. And the reason we do it this way is so that we can intercept those events, right? So for example, you'll see here further down in the process method, you will see that we're asserting whether the event is a call started or a call end. These are 2 different types of event, call started and call ended. And then accordingly, we're doing some application logic, right? We're either alerting the owner on the connection of the call, or when the call is ended, we're sending the owner the full transcript. And that's how you intercept and handle events in the process method here. So using this class pattern gives us more granular control. Specifically, we access the events that are emitted as part of the conversational lifecycle by the Line SDK. And if you want to know more about the events, you can just go to Cartesia, the docs.cartesia.ai site, click on agents here, go down to the SDK, and then look at the events. And you can see all the events here handled and described for you. Now, it's important to note that these events that we're looking at are not tool calls. They're different from tool calls, right? These are actually just events that you intercept at the application layer. So if you look at the process method, you will see that none of these are tool calls. These are actually just calling helper methods. And the reason we know that is tool calls, if you look at the documentation here, you'll see that tool calls have this decorator. So we're not using any decorators here. In fact, if you look at all these methods, alert owner on connect, and also the email owner transcript, they're here. You'll see that none of them have decorators. And that's because they're just application level logic, right? They're being called by the voice application themselves. So it's important to remember and separate in your head the application level calls and the tool calls. Now the tool calls can wrap these application level methods, helper methods, and we will be doing that in a sense in a bit. But these are currently being intercepted at the call application level in process, and that's how we're actually handling those events as application layer logic. Also, it's super important to understand the sequence in which we handle these different things, right? Now, in the old world, in the previous version of this code, we just, like I said, created the LLM agent here and we delegated it off to the agent so that it yielded its response. But since we're doing this class-based approach, we need to actually write the yielding sort of logic here, right? So we yield the output that we send to the LLM agent to process. But before that, we need to intercept and handle the events that we care about, being the call started event and the call ended event. So this sequence is important, right? You first assert against the events, handle them, and only when none of them have actually matched do you actually yield the output. So that's a pattern that's worth knowing for the class approach or the class-based approach to declaring your voice agent app. So we should now get clear on what actually happens at the start and the end of the call. At the start of the call, we fire off the set alert owner on connect method. And at the end of the call, we fire off the email owner, the transcript method, right? And in both cases, what we're doing is we're using AgentMail to fire off these emails, right? Both are going to the owner email, as you can see here. Both the email owner, the transcript, and the alert owner on connect are both going to the owner email, which is my email in this example, but with different subjects and text and actual purposes for these emails. And at the completely different points at the beginning of the call and at the end of the call. Now back in the actual email agent .py file, let's take a look at alert owner on connect so that you can see how we're identifying pieces of data from the voice agent's runtime and accessing that data in this method. Now you remember that the process method receives the environment object and the environment metadata, right? And we are calling alert owner on connect and passing it the env. So therefore this alert owner on connect method is going to access that object, and from it it's going to extract the agent ID and it's going to extract call request data from, so that we can identify the number if you're calling from a phone number, right? We'll be calling from the web, so that won't actually show up in that way, but it will actually pull off all this other information that you need at the runtime or at the call time and include it in the email to us. And notice that this call request has come from the self, so from the actual class, we've assigned call request here because we are passing it at the time we're initializing the digital agent twin, which you can see in main.py. We have initialized digital twin agent and passed in the call request, which is something that the line SDK passes into the get agent method anyway. So when this method gets called, it gets passed the call request data, and that call request data is what actually ends up having the originator, the end caller's details if it's available at that point. Okay, now you're probably wondering, okay, Zubin, well, how do we know if the caller wants an email transcript, right? Well, what we've done is we've actually updated the prompt, if you remember, and we've told the prompt, as we always do, hey, look, this is how we're telling the LLM agent, hey, these are the tools you have available, right? These are all the tools you have. And if the caller, in order to call the send transcript to caller method, which we haven't looked at yet, we will in a moment, we said, well, you have this tool and it's to email the transcript to the caller. Always ask the caller if they'd like an email transcript. If they ask for it early, then, just say, yeah, acknowledge and I'll get back to you on that. And then take the email address, right? Make sure that you have the email address. And if you don't have the email, ask for their email address and then confirm it out loud before sending. And that's how we have all the data we need to actually send the email. And how we implement this behavior about sending the caller an email is via the loopback tool, send transcript to caller, which is here at the bottom of the file. And you can see it's a loopback tool, right? It has the annotation. Now, if you watched the previous video, you'd be familiar with these annotations and what loopback tools are, but it's basically a tool that is called by the LLM agent, right? And it's given the access to the tool, it knows it exists, and it's called by the LLM agent. And then the tool's response is fed back into the LLM. That's why it's looping back, right? So it's fed back to the LLM before the LLM then generates the final response, which is converted by Cartesia's TTS into the voice, right? So this tool gets called by the LLM anytime it wants to send a transcript to the caller because the caller has requested for it. And underneath that, we call the build transcript. So the send transcript to caller method here calls build transcript. In fact, the build transcript is also called in a non-loopback method, which is not a tool, but an application level helper method called email owner transcript. We also call build transcript there because it's doing the same sort of function. So we factored out the building of the transcript into a reusable piece of code, and we're having different kind of email activity around it. But this one, the one where we send the transcript to the caller, is the loopback tool. The others aren't called by the LLM. Only the loopback tool gets called by the LLM. Now, it's important to notice that regardless of how it's being called, build transcript has to do a certain set of functions, right? It has to assemble the transcript by looking for two types of events that the Line SDK has or gives you access to. One is the user text sent event, and the other is the agent text sent event. User text event is basically, or user text sent is basically what we transcribe into text from the user's input on the phone or on the call, right? So they speak and it gets transcribed, and that's the user text sent. And then after the LLM call and after the agent has done its work and it's converted into a voice, into a text-to-speech voice from Cartesia back to the user, what the user actually hears, that's the agent text sent event, right? So we have to catch both of these events, and then we have to assemble it into a transcript array and then join it later on and separate it. And of course we try and give it, helpful information, like if there's a name, if the caller has given a name, then the LLM will pass that as a method as well, as a variable piece of data as well. And then we know the user's name is also included in the transcript. Otherwise it's just called caller. And likewise, we always know when it's the agent that's responding. And so that's going to be the agent's response and the content of that event. Now, the reason we do it this way is because we only need to access these two events, the user text sent and the agent text sent. That's because all the other events that are being passed between the agent harness, the voice agent app, and back and forth are all other pieces of data, but it's not actually relevant to the transcript. The transcript only needs what's said and the response from the actual voice agent. And finally, after all that, once we've built the transcript, we just send it using AgentMail to the actual end user, right? We assemble all this information and we send it off. And the LLM will pass things like the name of the user if it has it, and if obviously it's collected email, so it'll send that detail as well. And so we have all that information that actually goes into the creation of the email and then the sending via AgentMail. AgentMail is super easy to use. It's a very handy tool. Okay, we're almost done. So let's just quickly do a quick sense check over here to make sure that the app compiles. So we can do that by doing uv run main.py, and if everything's okay, it's going to compile and it says, okay, it's up and running. And then you can open, if you've watched the previous videos, you'll see that you can run Cartesia chat at port 8000, and then you can actually chat via text to the app right now. But there's not a lot of point in doing that right now because we're going to hear it out live, right? And I don't want to get extra emails so that I can show you what's going on. As long as it's compiling, I'm happy. Next, we're going to deploy and send it off. Okay, so now in the moment of truth, I need to stop the server because now I know it's compiling. I want to do a Cartesia deploy. And as you can see, what it does is it uploads it into Cartesia's hosted environment, and you'll eventually see it here. In fact, you'll see it's deployed and it's just starting just now. So it's starting to build over there in the hosted environment. And in a couple of seconds, we will be able to actually interact with it and speak to it. Now, here's what we can expect when I do start speaking to it, right? We can expect the moment we connect the call via the browser, we can expect an alert email. And AgentMail is very fast, so it'll all happen pretty quickly. And then I will pretend to be a recruiter and speak to myself, and I will ask for a transcript at the end. And then after the call, it'll send me the transcript. It'll also send my other email as the recruiter the transcript of the full conversation as well, but I'll also get an alert email. So there'll be 3 emails that the system fires off, 2 to me as the owner of the system and 1 to me as the caller. Okay, now let's connect with our voice agent and have a chat and see if it sends its emails. Hi, I am Zubin's digital twin. What would you like to know about my professional background? Hey, tell me a little bit about Cartesia and what your role is there. Tell me about the company as well. Sure, happy to share that. Let me pull up the details. Cartesia is a San Francisco-based AI company founded in 2023, focused on ultra-low latency voice AI and real-time multimodal intelligence. Nice, and you work there at the moment? Yes, I joined Cartesia in April 2026 as Head of Developer Relations and Experience. Awesome, that's all I needed to know. Look, thanks very much. By the way, can you send me an email transcript or email summary of this call or something? Of course. What's your name and email address? My name is Arjun, and my email address is... Just to confirm, I'll send the transcript to Arjun at... Is that correct? Sure. Done. I've sent the transcript to your email. Thanks for your call. Bye. Okay, and here you go. We can see a bunch of emails. I've blotted out a bunch of things obviously on the screen, but the first one, intentional new call connected. Here you go. This is the latest version. As you can see, the previous versions from testing. That's good. And then there was another one with the tension, which is, so the ones marked ATTN are the ones to me as the owner of the voice agent. And you can see the transcript is here as well. That's great. That's the correct email address, etc. And this is the one that went to the actual caller, right? And there you go. That's the full transcript. So there you have it. It clearly works. That's how you give your voice agent the ability to call tools, send emails, respond to customer requests, and so on. Very powerful stuff. Hope you got a lot out of that. As always, please like, subscribe, ask questions. All of us at Cartesia are very keen to hear from you and help you achieve your goals with voice AI. Reach out to the team. Anything that we can do for you, we're always here and happy to respond and help. Thank you, and catch you next time.